We have data engineering. What is a data engineering life cycle? Did I even read it? I haven't read it, so I'm gonna read this section first. So, if you work in data or software, you might have noticed data engineering emerging from the shadows, and now it's the state. Despite the current Despite the current popularity of data engineering roles, there are a lot of confusion about what data engineering means and what data engineers do. Data engineering exists in some sort of since companies started doing things with data, such as predictive analysis, descriptive analysis, and report, and come into sharp focus alongside the rise of data science in 2010s. For the purpose of this book, it's critical to define what data engineering is and what data engineering means. First, let's go to the landscape and how data engineering is described and develop some terminology we can go through as a book. Endless definition of data engineering exists. In 2022, a Google extract match search for what is data engineering returns over fuck you. Yes. I'm gonna break you. Returns over 900 unique results. Before we give our definition, here are a few examples of how experts in the field define data engineering. A data engineering set of operation aimed to create holy shit, I need to do a project. I'm such a faggot sometimes.
Today we are going to build end-to-end data engineering project using Databricks. Databricks is gaining a lot of popularity, and we will use this platform to build a project in FMCG domain that you can add directly to your resume. In terms of technical stack, we will be using Python, SQL, S3, Medallion architecture, Databricks dashboard, and Genie. We will be doing all of this in Databricks free edition. Yes, it is completely free. It doesn't even ask. ask you for your credit card. This edition enables students and practitioners to learn data and AI tools for free. For people who don't know about Databricks, it's a leading AI and data platform for enterprises. The reason for its popularity is its ability to simplify their architecture and speed things up at the same time. It has helped many companies like HSBC to perform analytics at scale while keeping it secure. All right, let's look at the problem statement for this project.
Atlicon is one of the leading manufacturers of sports equipment operating across several countries. For years, their operations ran on mature, ERP-driven systems, predictable, structured, and reliable. Recently, Atlicon acquired Sports Bar, a fast-growing startup in the energy bars and athletic nutrition space. But unlike Atlicon, Sports Bar's data is everywhere. Spreadsheets, cloud drives, WhatsApp exports, and hastily built APIs. Atlicon's leadership decided to retain Sports Bar's culture, teams, and processes, a respectful but risky choice. And soon, the consequences became clear. Their data formats didn't match, their reporting cycles didn't align, and some months of Sports Bar's data simply did not exist, lost during their hyper-growth phase. As Atlicon prepared to unify supply chain, forecasting, and inventory planning across both companies, the data chaos became a bottleneck. Metrics were inconsistent. Sales number conflicted, nothing tied together. That is when Bruce, the seasoned COO, known for solving operational puzzles, stepped in. He approached the data engineering team, led by Tony Sharma and driven by curious Peter Pandey, the data engineer. Bruce's request was simple but daunting. Give us a reliable data layer for both companies, something we can use until we fix this mess. And that sets the stage for this Databricks journey, where Tony and Peter team must massive formats, align metrics, fix missing data, and build a scalable foundation for a newly merged giant. Together with Tony, Peter, and Bruce, you will be solving this problem using Databricks Free Edition. Get ready, folks.
Tony, I saw the email from Bruce. Looks like we have a very short deadline.
Welcome to the world of data chaos, Peter. I know this was going to come, but not this soon.
Well, but the good news is team at Sports Bar is very supportive. Some of their data engineers know Databricks already. So we can do this, I guess.
You guess? No more guessing, Peter. We need to do this. Let me tell you, there are 3 success criteria for this project. Number 1, you should be able to provide the aggregated analytics of both these companies in one single dashboard. And the most important thing, the solution should be reliable. Number 2, the learning curve should not be very steep. Let's say we are going to hire a bunch of data people who can work on this too. I don't want that to be very difficult for them to learn. And number 3, this is also a very important thing. See if this can be a long-term solution. I mean, it should be scalable. Why I'm saying is that we can't trust right now. They're saying they will change the systems of Sports Bar in a year. But what if it takes more than 1 year? What if it takes 2 years, 3 years? We should have a solution that is quite scalable. So see if this can be a scalable solution. Okay, does it sound clear to you?
Yes, Tony, it's super clear. I'm excited to begin work on this project.
Great.
Before we begin the actual project work, let me clarify something. You need to know Databricks Foundation for this project. If you don't know it already, I have another video that you can watch. I'm going to provide you a link. And if you know the Databricks Foundation, then you can just continue further.
We already saw in the problem statement that Atlicon is a manufacturer of sports equipment such as cricket bat, badminton racket, volleyball, and so on. And it's a big company which has acquired this small company called Sports Bar, which makes energy bar and athletic nutrition products such as this bar and sports drinks and so on. Now, Atlicon has an established data infrastructure. So they have OLTP system where they have a proper web application, mobile app. You know, when you go to Atlicon store, you buy, let's say, cricket bat, you'll be performing a transaction, and all of that data will go into OLTP system. They also have OLAP system, which is your analytical processing, where they use Databricks, and they have bronze, silver, and gold layer. Bronze will contain all the data from OLTP, so it's a raw data. In silver layer, you will do data cleaning, you will do currency conversion, you know, some transformation and so on. And in the gold layer, you will generate BI ready columns. So you might generate some additional derived columns based on the raw columns that you have, and you might perform aggregation, etc. Eventually, you use gold layer to build BI dashboards in Databricks. You might also use Genie, which is an AI assistant. Okay, so this is a very nice data infrastructure that Atlicon has, but their problem is this small company that they acquired, they don't have a proper data engineering system. They have OLTP, and directly they are building Excel dashboards by pulling data from the relational database. Let's say if they're using Oracle, from that, they will directly build this Excel reports. And the management has decided that they don't want to get onto this multi-year migration project. I mean, they will do it eventually, but in a short term, management wants streamlined insights. So let's say if CEO of Atlic wants to know the revenue from both the products, you know, Atlicon products as well as post product, they need some single dashboard where they can see it. If they want to see top 5 products, it should aggregate both the products, Atlicon's and Sports Bar's product. So data engineering team came up with this smart solution where you will take OLTP of Sports Bar and you will dump that data into S3, AWS S3, okay? And then you will build a data pipeline for Sports Bar. So you will have bronze layer, silver layer, gold layer. You will do all the transformations, okay? And I have this line here which shows that when you're doing daily file processing, when the files are processed, you move it to archive, okay? So when we do coding, we'll actually see how it works. But the idea is this diagram represents the data pipeline for Sports Bar, which is a child company, okay? And once you have gold layer for a child company, you will merge that data with the gold layer of Atlicon, right? For Atlicon also, there is a bronze, silver, and this is a gold, right? So I have not shown this here. But this pipeline is established, so we are not making any changes to it. We are going to be mainly focusing on building the data pipeline for child company. And then we will merge this sports bar gold data with here. So now when you build a dashboard using this gold, you will have the aggregate products information from both sports bar as well as Athlon. In terms of data timeline, this project will be going live in production on November 30. So you have about 5 months data for sports bar. So when this merger happened, sports bar gave this 5 months data. I mean, their systems are containing 5 months latest data, and we will be doing historical backfill. So we will be doing essentially batch processing here, okay? So in data engineering, there's batch processing and there is live data processing. So for historical backfill, we'll use this 5 months data from sports bar. And then from November 30 onwards, for December, we will do incremental update. And as far as Athlon is concerned, as I said, in this project, we are not going to look into the data pipeline of Athlon, okay? We just assume that Athlon has a good data till November 30 in their gold layer. And in that gold layer, we will do first, so let's say there is a gold layer, right? So this is a gold layer of Athlon. So we will first do historical backfill of this 5 years data into here. And then from this point onwards, this gold layer will contain the incremental update from sports bar, okay? All right, so that was a quick overview of technical architecture. Let's now understand the data model, which is nothing but the structure of the data tables and how they are related or linked to each other. We are going to provide you this data folder where we have data for parent company and child company. If you go to parent company, you will find 2 more folders, full load and data load. Full load contains data till November end. Incremental load contains data for December 2025.
So, the sole purpose of data engineering is to take data from the source and save it to make it available for analysis. Frankly, it's so simple, like it's not even worth talking about. You click on a video and YouTube saves this event in a database. The exciting part is what happens after. How will YouTube use its machine learning magic to recommend other videos to you? But let's rewind a bit. Was it really that simple to put your click into a database? Let's have a look at how data engineering works. Okay.
Top 3 reasons why data engineering is a better career path than data. Top 3 reasons why data engineering is a better career path than data science. 1, it requires less education. Most data science roles require a master's degree, and some even require a PhD, and it's freaking crazy. Data engineering most often is a bachelor's of computer science, and there's even some data engineers I know who don't have any degrees at all. 2, you build more as a data engineer than you do as a data scientist. So if you like to build and like create things, you're going to create a lot more things as a data engineer than as a data scientist. As a data scientist, you're going to like discover and dig into the data a lot more. And number 3 is data engineers are just empirically sexier than data scientists. Top 3 reasons why data engineering is a better career path than data science. 1, it requires less education. Most data science roles require a master's degree, and some even require a PhD, and it's freaking crazy. Data engineering most often is a bachelor's of computer science, and there's even some data engineers I know who don't have any degrees at all. 2, you build more as a data engineer than you do as a data scientist. So if you like to build and like create things, you're going to create a lot more things as a data engineer than as a data scientist. As a data scientist, you're going to like discover and dig into the data a lot more. And number 3 is data engineers are just empirically sexier than data scientists.
Hi, what's your name?